We're going to talk now about the high pressure cylinders. We use this, of course, for many of our systems, either reactors or analytical equipment. And the most commons we use helium, nitrogen, argon, air, and hydrogen. And sometimes we use other flammables like propylene, ethylene, depending on the application. The full cylinders and the empty cylinders that are not being used, we usually keep outside the lab, and you may have seen outside the labs we have these banks of cylinders. Now this bank right now is a little big. They allow us to keep the cylinders outside the lab as long as they don't come in the corridor space. So for example, here we have 2 extra cylinders, and the reason why these things happen, and we have had this, we have been improving in this, but still there are more improvement to do, is that we order too many cylinders and then there's no room to put them. Or people take out empty cylinders and they don't order a pickup so that they can take the cylinders. So the cylinders start to accumulate. So please make sure if you are taking out an empty cylinder, you can go upstairs to Bernita. You tell her what is so these cylinders, they have an account number in the tag. So you go up to Bernita, you tell her what is the account, and you tell her you need a pickup sticker. And she's going to give you a pickup sticker, and you come and put the sticker here, and that way we make sure that all the cylinders, the empty cylinders, are being taken outside. The cylinders, the chains should always be surrounding the cylinder, and it should not be just like a necklace, you know, it should be something that is tight. So, for example, this one is a little loose right now. So always make sure that the chain is tightened so that it's actually holding the cylinders. If one cylinder falls and the chain is not holding it, then it's gonna make a mess. Now we are gonna, whenever we need to take cylinders from the bank to the place where we are gonna install it, we have these cards, and you can find these cards outside of Alan's shop, and they have a chain that you can use to secure the cylinder, and always try to keep it tightened. When you are transporting the cylinder, always make sure the cap is installed. Do not transport cylinders. And these cards are only for transportation. These cards are not for permanent use of the cylinders. We've had people in the past, they bring the cylinder with the card and they connect to the reactor and they leave the cylinder in the card. This, as you can see, this doesn't have any brake or anything to secure it. If someone pushes the cylinder, it's going to break a hose that is connected to the reactor. So the cards are only for transportation. If you need to use a cylinder for an experiment, make sure you find a clamp and you clamp the cylinder, fix it to a top counter or to a structure that the cylinder is fixed and is not moving. Now we're gonna take this cylinder inside and we're gonna show you how to change the cylinder.
Oh my God, this is here.
Va a estar complete. Okay guys, try to get closer so that we can see here. Okay, so here we have this bank of cylinders that are all connected to these reactor systems, and we use these flexible hoses that go from the cylinder to the line. Now these hoses have flexible but still somehow rigid core. So make sure that the hose doesn't have any small angle of bending, because that's gonna break the hose. So always make sure that the curvature of the hose is not so sharp. Actually, if you look at the manual of these hoses, they show what is the minimum curvature, radius of curvature, so that the hose doesn't have any problems. And so let's say a cylinder is installed. Most most of the times when you are going to change a cylinder is because it's run out, so probably the line doesn't have any pressure anymore. However, sometimes you need to change the cylinder and the cylinder still has some pressure. So in that case, you need to make sure that you release the pressure that is in the line before you remove the cylinder. So in that case, what you will do is you will close the valve of the cylinder, and what you're gonna do is for example, all these pressurized systems, they have a vent line. So the cylinder is connected, and you can just open the vent line, and it's gonna release all the pressure that is in the line. And then you can open the connection to the cylinder safely because there is no any pressure in the line. Okay. And now we're gonna change a helium cylinder. I believe is this one over here.
GCFID.
Yeah. Now the way we know now that there is no pressure, so we have here for this cylinder we have a regulator. We have here the GC helium, and it shows pressure of 0, and it is open. So that means the line is empty, so we can safely open the. I know it's a little hard to see, but basically I'm gonna close the valve that is already closed, and we have we're just gonna use an adjustable wrench to loosen the connection to the cylinder. So we have loosened this. Now we're gonna unchain the cylinder and remove the empty and move the new cylinder. Okay, first of all, before we move the cylinder, we're gonna put the cap. So here we always have the caps from the cylinders. Tag, if you see, it has different slits that you can remove. So when you take the empty cylinder, make sure you remove the one that says in use, so we know that it's an empty cylinder. I'm going to remove it here. Now we know that this is an empty cylinder. So I'm gonna. Unfortunately, we don't have like a place where we can secure this empty cylinder while we put the new one, so we just need to be cautious. So we're gonna set it here for a moment, and I'm gonna take the new cylinder. And again, if you can show here, this is the new tag, so it has the full. So since we're gonna install this, I'm gonna remove so that it has now the one that says in use. And I'm gonna move this cylinder over here. And now I'm gonna put this one in the cart. To the bank. Okay, so now we have the new cylinder here. I'm gonna remove the cap. And just place it here. For the new cylinders, they usually have the seal that means they're new. And now I have the hose, and again I need to make sure that the curvature of the hose is not too sharp. So in this case, in that position, that's a good curvature. I'm going to hand tighten this. Some of the cylinders, sometimes the hydrogen cylinder, it has a different thread than the, so it's more, the flammable cylinder has a different thread than the non-flammable cylinder. So one is clockwise, the other one is counterclockwise. So if you don't remember, not all the cylinders, but a lot of them, we have written in which direction you open and in which direction you close. So that makes it easier because sometimes you are tightening more and what you need is to open. So look for that. If it doesn't have it, then you can ask someone if you don't remember whether it's clockwise or counterclockwise. Now what I'm going to do is just tighten this. Again, as we talked before, do not over tighten the connection because it can damage the nipple and the thread that it makes the seal for the seal. Okay. Now we need to make sure that the connection doesn't have any leak. We have what is called Snoop, and this is just a liquid that makes bubbles easily, and we use this to check that there is no leaks from the cylinder. When we have a flammable gas, we have some detectors that are for combustible gases. So in each of the labs, you're going to see one of these detectors, and they're electronic detectors for flammable gases. And we're going to see, so these work with the battery, so if sometimes they start to make a weird noise or they're not working, the charger is inside the box, so you can charge, and it has the head here that you use to detect the gas, and it has an on-off button switch, so you're going to turn this on and it's going to take a little bit until it starts to, and you can adjust the sensitivity of the, so it has a knob, and when the knob is at the minimum, the sensitivity is the lowest. As you move the knob, it's going to increase the sensitivity, and you're going to keep increasing until you reach the critical sensitivity, which you're going to know by the pace at which the tick is going. So it's going down, and if you, so over there, that's the, so you want to be right before it starts the continuous beat, because that's going to give you the highest sensitivity. And then what you do with this one, you just go to the connection, and then if the pace at which it's beating increases just a little bit, that means there is a leak. Now the helium is not flammable, so we don't need this detector at this time, but for hydrogen, anyone who is going to work with hydrogenation reactions or working with flammables, always use this every time you are working with your reactor, every time you change a cylinder, always use this detector, because the snoops sometimes, for small leaks, especially hydrogen, which is a small molecule, it cannot be detected sometimes if there is a leak with the snoop. So I'm gonna put some snoop here to make sure that there are no leaks. And then you just wait a little bit. If there are no bubbles coming, then that means there is no any leak. We don't have any bubbles, so the cylinder has been, well, I have not opened the cylinders.
Yeah.
Okay, we're gonna open the cylinder.
No bubbles, yes. It's fine. Boom.
Because it's lunchtime, you see? Okay, so now we see here the cylinders, usually this size, it has 2,500 pounds, and we can see that in the gauge. Now we're gonna use this loop to see if there are leaks or not. Okay, so it's good. This is not toxic. I think this is just some water and some salt. So I got a little bit in my hands, but this is not bad. Okay, I think that's it. Now we're gonna take the cylinder back. You guys have